In this video, we're going to go over an AP Physics C kinematics type of problem. So in this problem, I'm going to have a building that is of height h. And from this building, I'm going to have a ball. I'm going to call this ball 1 that is dropped from rest from the top of this building. At the same time, so this is happening at time 0, and at the same time, I'm going to have a second ball at time 0. This is going to be a second ball launched with an initial velocity of v0. Okay, and so the problem here will be to find the time ball 1 and ball 2 pass each other. So this one's being dropped and this one's being launched upward, and basically there's going to be some time when these two balls, some unknown time, 2, 1, will pass each other, and we need to find this time. So this time will be equal to something, and this expression will be in symbols. So pause this video and try to use your kinematics equations to find this time. Okay, so now we're going to go over the solution to this problem. So over here, we have ball 1 and 2, and so I'm going to just say that the time at this occurs, ball 2 has gone up some amount that we don't know, x. So if ball 2 has gone up x, for 1 and 2 to have passed each other, then this will be h minus x. This is the distance that ball 1 has dropped, and x will be the ball 2 has come up for them two to meet. And again, we don't know what this x is. We don't know the distance that ball 2 meets 1, but I'm just going to call it this variable called x. So now with these kinematic equations, I like to break it apart, and I'm going to first look at ball 1. And so in these problems, I like to list everything I know with the object. And so our 5 variables that we're concerned with kinematics is initial velocity, final velocity, the time from the initial velocity to final velocity, acceleration, and distance. Now again, in these types of problems, our acceleration is constant. So in this problem for ball 1, we know ball 1's dropped from rest. So I know my initial velocity is 0. Now I don't know anything about my final velocity, and time is what we're trying to find. Here the ball's dropping, and so it's in free fall. And so one assumption, since usually problems will state, or one assumption we'll have to make, is that that there is minimal air resistance. Sometimes you'll see that in these problems. So basically what that means is that it is okay to have our acceleration assume that to be a constant for free fall g, where g is negative 9.8 meters per second squared. But in this problem, I'm just going to use the symbol g. And then we know the distance will be, it's fallen negative, and we know something that's going to be h minus x as an expression I'm going to use. And the reason I have this negative here is because the ball is falling down. It's going in the downward direction. Okay, so now let's do the same thing for ball 2. So here, my initial velocity is v naught. My acceleration is again g. And the distance is positive x. And again, we're trying to find t. So we're going to use the kinematic equation that does where change in x is equal to v initial times t plus 1/2 at squared. And so for this, it's really important to know for the AP exam to know your kinematic equations really well. Okay, so in this case, I'm going to apply this equation. So our distance is negative h minus x. And so our initial velocity is 0. So this term right here is going to be 0. So this is going to just be equal to 1/2 gt squared. Okay, on this side, we've traveled x equals v naught t plus and 1/2 gt squared. And now basically we have a system of two unknowns, x and t, and two equations. So what I'm going to do is I'm going to first simplify this equation here. So I'm going to work in this space here. So that turns out to be negative h plus x equals 1/2 gt squared. Now I'm going to multiply this whole equation by -1, and you're going to see why in a second. Negative x equals negative v naught t minus 1/2 gt squared. Now the reason I did that is then I'm going to add these two equations together. So these x's cancel out. I get negative h equals, and another thing that will cancel out is this 1/2 gt squared, this negative 1/2 gt squared. So these two cancel out. So then I'm left with negative h equals negative v naught t. So the time it takes will be h divided by v naught. And if we look at the units, h is usually, let's say that h is in meters, and v naught is meters per seconds. This turns out to be seconds. So that's a good way to check that your units match up. And so the time it takes is equal to our h, the height of the building, over v naught, which was the initial velocity of ball 2. Thanks for watching.